Thank you all for joining my session today. My name is Allison Wu, and I'm a data scientist in the Data Science Center of Excellence in Thermo Fisher. Today, I'm going to talk about how we enable scalable data science pipelines with Mlflow and model registry in our company. So before we go into any details, I'd like to give you a high-level summary of what we have achieved in this progress. We have standardized development of machine learning models by integrating Mlflow tracking into the development pipeline, and we also improve the reproducibility of machine learning models by having GitHub and Delta Lake integrated into development and deployment pipelines. We also streamlined our development process and deployment process for machine learning models on different platforms through Mlflow and Centralized model registry. Why these are so important for our team to set up is also highly relevant to what we do, what we data science do in our Data Science Center of Excellence. So what do data scientists at our Data Science Center of Excellence do? We generate a lot of new novel algorithms that can be applied across different divisions, and we work with cross-divisional teams to migrate models, and in this kind of cases, model standardization is actually very important for both productivity and reproducibility. A lot of migration and standardization are oftentimes needed for enabling new data science into a new division. And while doing all this, we also are responsible for establishing data science best practices across the company. So there are multiple fields of data science that's rapidly growing in data science. For example, operations, human resources, R&D, and commercial marketing. And we're actively engaged in all these kind of areas. But today I'm gonna focus on commercial marketing. Okay. So, what does commercial marketing data science lifecycle look like? So at first, we have all this kind of all different data pipelines of piping all kinds of data, including transaction, web activity, or install-based data from customer interactions. And we use all different these data pipelines of piping to the same data lake that's needed for data scientists to consume for model development and deployment. And we have both machine learning model and rule-based legacy model that's running currently in production. And for this would be the phase that we will be focusing on a lot today, especially for development and deployment. And for this process, we involve a lot of new technology in Databricks, such as Spark, Mlflow, Delta Lake, and we'll also have GitHub integrated throughout this process to help us with reproducibility. And after we develop all this model would deliver results, recommendations through different channels, such as email campaign or website, or we also generate very prescriptive recommendation for our sales rep through Salesforce or Adobe Analytics. And all these are meant to provide the most relevant offers for our customers. And how the model performs are measured by the revenue generated or engagement rate for each recommendation. And all these will eventually be feedback to both model development or deployment phase, or could potentially feedback to data processing pipeline in order to, for example, bringing in new data to help us understand our customer more. As we are focusing on the model development deployment cycle, let's take a closer look at what each phase involves. So in development phase, this means like exploratory analysis or model development, such as feature engineering, feature selection, model optimization, all these different good stuff. And as data scientists develop their model to a certain point that we feel it's ready for deployment we move the model from the development environment into the production environment. This is a process we call deployment. And during deployment phase, when model is running in production, for a model that lives in production, it can go through a few different processes. For example, like it has to be run for every day scoring, and it all can also need to be retrained or retuned every certain period of time. And this can all be done in our production. And in order to monitor all these processes, we have another process called management that monitors all these production runs to make sure our model are producing accurate results, or it can also alert us whenever there is weird events going on for models that's running in production. And a lot of the times we also track feedbacks through this process, and these feedback will either feedback to deploy to models in production, or we can also feedback all the way back to development phase in order for things such as a new model development. So, and then one thing that I'm not going to talk about today, but it's also a very important stage, is the delivery. And we can deliver all the delivery is done through using recommendation that's generating in production environment. So production environment result feed into different delivery channels like web recommendation or email campaigns. So let's take a closer look at an example model in our pipeline. So this is a model that generates product recommendation based on different customer behaviors, such as web activity or sales transaction. And this model spent about 6 to 8 weeks in exploratory analysis and model development and prototyping. And then after development, it was moved into production, and it's mostly run in 2 ways in production. One is it's doing daily scoring. So what it means, it generates new input metrics based on new data, and then run through the same model every day to make sure we get the most accurate prediction based on new data. And then after this model is also retraining, you retune with the latest data for every 2 weeks. And then this model the recommendation from this model is delivered through email campaign and also through our sales reps dashboard to recommend them who is the best customer to engage with for this specific product. And then the very last part is the management part, that this production process is also monitored in our production environment through Mlflow. And so what we used to do is that in development is that we have a bunch of Databricks notebook, and there's no version control of any of the notebook, and there's no unit testing for our feature functions or anything. And regression test is very hard to do, especially if you're inheriting a notebook from a previous colleague. And this is the situation that we are probably all pretty familiar with, that we have multiple versions of final notebook, and we confuse ourselves, and we confuse ourselves with what exactly is the one that we should be used. So what we do now is that we still in development environment, we still use Databricks notebooks for exploratory analysis on like feature engineering. But once we get more comfortable and feel the feature has matured, then we actually write it into Python modules and Python functions that are version controlled into GitHub. And each machine learning features are actually independently are testable and shareable. So aside from integrating GitHub, we also integrate Delta Lake to version control all our data that are used to train our models. This way, combined with Mlflow, we also are able to track a machine learning model development. So we can track all the hyperparameter tuning and how feature selection is going in different experiments. And by the time we feel more comfortable with the model in the development, and then we can actually register it into the development stages model registry. This actually makes the regression testing against previous versions of model way more easier because it provides a cleaner interface for us to pull out the previous version and look at how these two model compares. So I will have a few demo on that as well. So here are a few scenarios that we can look at and to see how exactly this process improve our development. So first tracking feature improvement becomes a lot easier. How does that go? So we all have run into this. Our boss come over and ask, oh, what are the important features in this version versus the previous version? And what we used to do is that, let me find out how the features do in my model version number 10 notebook. And sometimes I wish I had saved a screenshot for the feature importance figure, and I didn't. Too bad. So, sorry. And I believe this is what we are all familiar with, is that we have so many different final versions that we don't even know which one we should pull to get the data from the previous version. And how do we improve that? So now what we can do is that, sure, we'll just pull it from Mlflow. And this is how it would look like. So this is the video. So here we can see there are multiple Mlflow runs that are logged into an Mlflow experiment. And now since I want to compare with a previous version, I can just click and choose a few different models that I want to compare with. And then we can go into each one and see the feature importance figure actually locked together with the model. This way we will know and no longer need to worry that, oh, I did not log feature importance figure this time, because we can all log it through Mlflow, and it will only always be tracked. So now also sharing machine learning features also becomes a lot easier. One of the common scenario is that a colleague will come over and ask me, oh, I really like the feature you use in your last model. Can I use that as well? And what we used to do is that, just copy paste this part of the notebook, but well, I have a slightly different version in this other part of the notebook. I think I might have used this one. This is usually not the greatest idea, because we oftentimes confuse ourselves and not sure which one to actually share. And it's also really hard to track the changes over time for these functions. Now with GitHub integrated into our development workflow, what we can do now is that, sure, I added the feature to the shared machine learning repo. Feel free to add it, use it, and by importing the module. And sorry. Can we? Sorry. So what we now can do is that, sure, I added that feature to the share ML repo. Feel free to use it by importing the module. And what's even cooler, and look, you can see on the side here, is that Magna is our internal share machine learning repo, and all these feature functions are testable functions that we can write a lot of unit tests to make sure it does fit in all different kinds of situations, and also make sure in the future, if anyone modify the function, it doesn't break all the other people's code. And what's even cooler is that you can also log the exact version of the repo you use in into Mlflow. And here you can see that we log the environment setup, the conda YAML, and also the source packages. That's how we make sure we always log the exact version. And this also makes sure that even if the repo continue to evolve after your model development, you can still trace back to make sure you know which version you use for your own model. And this way, you can always reproduce with the exact same development dependencies and environment setup. So what we learned for improving this development process, reproducing model results does not just rely on version controlling of code or notebook, but also version controlling the training data, environment, and dependencies. And Mlflow and Delta Lake allows for tracking all these necessary things needed for reproducing the model results. And integrating GitHub also allowed us to establish best practices of accessing our data warehouses and also standardize our machine learning model. And it really encouraged collaboration and review among different data scientists. And personally, I think the last one is a big plus, as since data science a lot of times work in silos, and having a collaborative platform is so important for data scientists to grow. Okay, so let's talk about deployment. So what happens all the time is that things work in development and everything breaks in production. And how can we streamline that process? So what we used to do is that we manually import and export all these Databricks notebooks that's needed for deployment. And also we manually set up all these different clusters in production based on development clusters in development cell. And this makes troubleshooting super hard. And what ended up happening is a lot of times data scientists come in on Saturday to get and sit alongside with data engineers to make sure their model can be deployed correctly without error. This is not something we want. And we will always so we have tried really hard to streamline this process. And what we now can do is that we register our model into development model registry, and then in the product, and then we can move all the artifacts that are needed to deploy the model from development environment into the production environment by registering the model and copying all the artifacts into our centralized model registry on our production environment. This also makes regression testing within the production environment very easy, because you can actually move the model first into staging on production, and then now that the staging and the production model are in the same environment, and you can easily do comparison and testing within the same environment. This also allows us to have easier way to track and monitor our model. So you can see that in the centralized model registry, now we have different versions of models in there, and we can easily manage across different versions to make sure which ones and we can clearly know which one are in production, which one are in staging. And we can use the notebook to still execute all these model pipelines, and we use Mlflow to track how the model actually performs in production environment. It can track specifically how the output of the model, and so whenever there is some weird events going on, we can get first alerted. This another thing is very important, that centralized model registry allows us to manage model across different environment and different platforms. Some of our data scientists on different teams like to use Databricks. Some of us like to use SageMaker. And both SageMaker and Databricks, they can all register through the same centralized model registry, and they can also be deployed to different environment based on the original input. So here I'm gonna have a short demo on how we can register the model from development environment into production environment.
Here's a demo of how we could register models from development shard to the centralized model registry on production shard. Today, as a demo, I will deploy to our test shard instead of our actual production shard. In reality, this is a way to use model registry as a hub to manage models developed on different platforms. This is a new feature for Mlflow and only works with Mlflow 1.8 and above. So before we start anything, we need to set up the credentials so that when you reach out to the production shard, it can authenticate that it's you. You'll need to create a token on your destination shard first and use the token as a handshake from your source shard. You can store these credentials in your Databricks secrets and create a Databricks secrets Databricks profile here on your local shard. Now you're all set up for the connection between the source and the development source and destination shard. You can see it here, and then we can start finding the model that you actually want to register from your source shard to your destination shard. So you can see it here. In order to find the run ID, you can either pull it from a model registry or from an Mlflow experiment. However, it's usually a better practice to deploy to production using models that are already registered and approved in model registry. So this is what I'm going to demo today. So here is how you can create a client for Mlflow tracking server, and then this is how you can specify what model you want to pull. So this directly pulls the latest version of the production model in this model registry. And this will give you, this code will actually give you the actual absolute path for all the artifacts that you register for the model. So by parsing this artifact path, you can get the experiment ID and run ID as well. So experiment ID is usually this one, and then run ID is this one. So after we got the experiment ID, run ID, and know exactly where the model is, we can transfer the model from the local tracking, local workspace to the destination workspace. And here is how you can do it. And you can see here, you just need to give it a run ID and run ID, artifact path, and artifact URI, and then it can initiate the copying over. And here you can see it's copying over the model that we specified. And here in this case, it will preserve the exact same artifact path on between the destination and the source shard. So what experiment that also in that case it also preserved the experiment ID and run ID. So as the third step, what you can do is to actually create the registry on the central model registry and point the registry to that actual model by registering the model with the source ID that you just transferred to. So here it will actually just need to specify the run ID you just derived from the local model registry. As I said, we are preserving the same run ID on the source shard and the destination shard. So on the destination shard, the run ID would be exactly the same. And in order to create that model registry on the remote server, you have to create a remote client here using the tracking URI we just set up. And so this is how you can create a model version using the model you just transfer from the source to the destination shard. And then you can also update the metadata on the remote central registry. I usually save the source workspace information, also run ID. And also if your security allows it, you can also put in the run URL. And this is what it would look like in the destination shard. What you can see is it has the dev source workspace and also the run ID, and you can also see the run URL. It will point to the most original experiment run, and I can actually click on it to see what's over there and what the performance look like and how I could reproduce this model. And it also include the feature importance that a model performed with. Okay, so okay. So this is how you can, and then you can also update model version to production if you want, all through this remote client you set up on the local shard. So this is how you can register a model to Central Model Registry. And what I'm going to demo the next is actually how you can use the model. So remember what I mentioned that for our model that's in production, a lot of times we also we use that model for daily scoring, and sometimes we need to retrain or retune maybe every 2 weeks or every month. So this is a demo of how I can use the model in the production model registry to do daily scoring and use Mlflow to monitor the output. So here is how first how we can take it's the same, similar to what we just demoed in the other notebook, how we can get the artifact path for the model. And then one thing that's very important and what we mentioned before is that we want to make sure we install all the right dependencies in order to run the model. So here is actually how I can unpack all the source packages, tuple, that are locked together with the model. So this is how I pull it from that artifact path, and then unzip it, and then pip install all the packages in that folder. And then here is how I can pull all the package, install all the package, and then now my environment is all set up, and I can run the daily scoring. And here I do actually start an experiment so that I can log all the metrics I want to monitor for this model. So in this case, I'm only doing scoring. So so what I'm gonna do is that do scoring, and then I bring in these are the modules that I actually install with the source packages, and that means I'm using the exact same function to produce the input metrics. And after I produce the input metrics, and I can actually version the input metric with a Delta Lake. So here I actually override and then save the input metrics into a Delta Lake file. And then after I generate an input metrics, I can load the model directly from the model registry, and also by specifying I want to run the production. I just need to specify which version I want to run and what model registry I want to go get the model. So this way I got the model, and then I can run it using the new input metrics I generated that day, and then I can get all my predictions. And at the end, I will log all these parameters that I use to run this time. For example, the artifact path and all the what stage of model that I pull from, what's the model registry name, and what's the prediction date I use for this one to generate the input metrics. And I also log some metrics for scoring. So for example, like the total row count sometimes, or if it's binary classification model, sometimes I also log how many positives I get and how many total negatives I get. If sometimes I can see a huge spike of positives, then I know something is wrong with the model.
So this whole process also makes regression testing becomes a lot easier. So a lot of times we want to compare two different models, and then what we used to do is that we have to dig through all the previous colleagues' notebook and then find that maybe the performance metrics is not even logged. And what we now can do is that we can pull it directly from Mlflow and compare them. So there are two versions that we can choose to compare, and then we can just choose them and compare in the model registry, and then we can see all these different metrics that we logged side by side for these two models. And for example, the validation sets area under precision recall, and then we can also compare them this way by looking at this and see how different features affect these different model and how their performance under these two different settings. And now troubleshooting transient data discrepancy also becomes a lot easier. A lot of times data engineers come and ask us why the run yesterday yield a weird number of predictions that's not usual. And what we used to do is it's really hard to troubleshoot this kind of problem because maybe today's run already overwritten the input tables. So what we now can do is that because we version control all our source data through Delta Lake, we can load the specific version that were used for yesterday's model to troubleshoot this kind of problem. And it makes that a lot easier. And you can see on this side, on the right side, that we can load, even though it's the same Delta Lake file, we can load the specific version of it. So what we learned from this improving this deployment process is that data scientists really like the freedom of trying out new platforms and new tools, and allowing for the freedom of platforms and tools. And this can be a nightmare for deployment in production environment. However, Mlflow tracking server and model registry really allows logging a wide range of flavors of machine learning models, from Spark ML to scikit-learn to SageMaker. This really make the management across different platforms in the same centralized workspace possible and easy. Thank you all for joining our session today, and I would really appreciate any feedback from you all. Thank you all so much.